Hello guys, welcome to another tutorial session of the Applied Electricity Rights course IoT. So today we are going to talk about basic circuits, right? Basic circuits analysis. That's the first session. We are going to group it under two sections. The basic circuit analysis 1, which will be made of the Ohm's law. We'll talk about the voltage division and we'll talk about the current division. You get it? So we are going to talk about these ones in this video. So please tighten your seatbelts. And if you've not watched my previous videos, please try as much as possible to watch it. I know that some of you have started classes, IoT. And don't worry if you go there and you are still struggling to understand the concepts. Just follow me on YouTube, IoT, and watch my videos. And trust me, I'm going to make sure you understand every corner of the course. You get it? Yes. So if you've not also joined my Telegram page, please try as much as possible to join it. I'm waiting for more people to join IoT. Some of you are struggling joining it. Some of you are really struggling joining the Telegram page. Please, and I'm pleading with you, if you are struggling to join, just send me a WhatsApp message. You get it? Send me a WhatsApp message and I'll personally add you to the group. IoT. So join the Telegram page. And let's move on. At the Telegram page, you can ask any question that you want to. You see, I cannot address your questions on YouTube. So you watch me here on YouTube, and if you have any question, you ask on the Telegram page, and I'll answer you well. You get it? As you ask the question, maybe it will be bothering someone's mind, and the person will also get to understand what we are doing here. So please, I'm pleading with you, join my Telegram page, and also send me a WhatsApp message if there is a need. Watch all my videos and don't forget to subscribe. Right? It's very, very important. I tell you that's the only way you can pay me. So you subscribe to my channel and you click on the notification bell icon. You get it? So that if I drop any video, you'll be able to get hold of it. So please subscribe to my channel. IoT. So once you subscribe to my channel, you are going to get a lot. IoT. You're going to get a lot. And you are going to also pay me in return. So please subscribe to it. So let's move on. We will first start with what? With the Ohm's law. I know Ohm's law is very, very, very simple. Right? And I'm not expecting anyone to struggle with it. So what is Ohm's law? For instance, I have a simple circuit. IoT. And I have a simple resistor here, which is called R. IoT. So with this one, we assume that a current is what is flowing through a circuit. You get it? We're just having a resistor too at this point. So we have the resistor here, and we have voltage here. You get it? We'll be memorizing this right from senior high school, and we have a condition that's at a constant temperature, right? At a constant temperature. This one is very, very important. At a constant temperature, right? The voltage is proportional to what? The current flowing through the circuit. IoT. So let me use this symbol of proportionality. This one looks like A. So with this, I'll say the voltage is proportional to what? The current flowing through the circuit. So this is basically the idea for Ohm's law, right? And it's happening at what? At a constant temperature. So at a constant temperature, the voltage across, let's say, a battery is proportional to what? The current flowing through the circuit. IoT. And if you should break this down, we have V equal to what? IR, right? Where the R represents the constant. IoT. R is constant. You get it? So R is constant, and that's all. So this is the general formula for what? Ohm's law. We have a lot of applications under Ohm's law. You get it? We have a lot. Ohm's law help us to even understand the KVL and KCL. right? That is the Kirchhoff current law and the Kirchhoff voltage law. So it helps us to understand the laws very well. Then we need it in most of the circuit analysis. But I'm going to show you one secret here. I'm going to share one secret that most students do not know. But if you get to know it, it's going to help you a lot. And what is that secret? Source transformation. Source transformation. You know why we need source transformation? We really need it in circuit analysis. Why? Because sometimes the circuit can be so complicated. You can get a complicated circuit. And once we get a complicated circuit, it can be very difficult to analyze it. But there's only one thing that can save you some of the circuits. There's only one thing that can save you. And what can save you? The source transformation. That is the favorite application of what? Ohm's law. Take note, I told you that we have a lot of applications. We need it in solving KVL, KCL, and a whole lot of circuit analysis. But you see, the secret that most people do not know, they struggle with a lot, is the source transformation. So I'm going to apply the Ohm's law in source transformation. So let's move on. Okay, so Ohm's law has given birth to what? The source transformation that I want us to discuss. So this is application of Ohm's law. Are you okay? Let me change the thickness of mine. I'm coming. So source transformation, right? Transformation, right? And that is application of what? Ohm's law. So application of Ohm's law. Right. I want to talk about the source transformation. Assuming I have a resistor, right, in series with what? With a voltage. In the circuit, I have a complicated circuit, and in the circuit, I have a resistor in series with a voltage. Right. The rule states that I can change this circuit, right, to a current which is parallel to what? To a resistor, and vice versa. So that resistor here, I can change it to a current which will be parallel to what? A resistor, and vice versa. So let me make this I. Do you get it? And how do we find the direction of the current? The direction of the current is very, very important. Are you okay? So in my analysis, I'm going to always consider conventional flow. So with this one, let's assume that the current, the first circuit, right? Let me call this circuit A, and let me call this circuit B. Are you okay? So let's assume that in circuit A, the current is flowing from what? The negative to positive. That is conventional current flow. Are you okay? So in that case, then the current will also be flowing from what? Down to up, or it will be flowing upward. Are you okay? So that is it. That's going to be the direction. And how do you find the magnitude? So it will be flowing upward like this. And how do you find the magnitude of the I? If you know the magnitude of the V, how do you find the magnitude of the I? That is where Ohm's law comes to play. Are you okay? Ohm's law states that V equal to what? IR. Right? So what's going to be I here? I is going to be what? I is going to be V on what? On R. You get it? So to find this I here, you just state that I is equal to what? V on what? On R. This R. To get the value of the I. The value of the R remains the same. So if here is, let's say, 3 ohms, right? This will also be 3 ohms. But let's assume the V here is 10 volts, right? What will be the current? Let me use a multiple of 3, okay. So let me say it's 15 volts, right? What will be the current here? The current here is going to be what? It's going to be 15 on 3, which is going to be what? 5 amps. So it's very, very, very important, right? Understanding Ohm's law will help you what? Understand source transformation. And source transformation is very important. My brethren, try to understand source transformation because it can save you from solving complicated circuits during a very long time. Using a very long time in solving a complicated circuit. If, let's say, I understand source transformation, I can use just 2 minutes or even less to solve a circuit that someone will spend about 3 minutes, or let's say 5 minutes, 6 minutes or above in solving it. Source transformation is very, very important. So what is the rule saying? If I have a resistor, right, in series with a voltage, then it means that I can convert it to what? A current, right, in parallel to what? A resistor. Let's assume I also have a current in parallel to what? A resistor. Wait, you come in. Okay, let's assume I have a current, right? This time it's moving downwards. Okay. Parallel to what? A resistor. Okay, let me draw it this way. It's not always vertical. Sometimes it can be horizontal. So let me draw it this way. Let's assume I have a current, right, which is parallel to what? A resistor in a complicated circuit. So I have, let's say, 18 ohms. 18 amps. And let's say, let me make this one 6 ohms. I can change this. I can change this to what? A voltage. Right, in series with what? That resistor, which is 6 ohms. 6 ohms. Someone can draw the resistor here and the person is still right. You can draw the resistor here or you can draw the resistor here. You are still right. So for us, they are in series. You are right. Are you okay? So I'm drawing the resistor at this point, but you can draw the resistor here. And once you draw the resistor here, you are still right. You are not wrong. Do you get it? I've repeated myself over and over again so that you understand the concept very well. So now, how do we find the polarities of the voltage? We always focus on what? The conventional flow. Since it's moving from what? From this side, or some people can see it at left, others can see it at right. So I'm seeing this as left. Do you get it? So since it's moving from left to right, okay. Here is going to be negative, and this place is going to be plus. That is, the current is flowing this way. Okay. And what will be the value? The value is simply going to be what? I times R. And this is going to be 18 times 6. Okay. 18 times 6. 8 times 6 is 48. 8 remainder 4. 6 1 6 plus 4, which is going to give us 10. So it's going to be 108 volts. Do you get the concept? Yes. So I've saved myself with source transformation. I've been able to convert this current in parallel to the 6 ohm resistor to what? A voltage in series with what? The 6 ohm resistor. So source transformation is very, very, very important. Source transformation is very, very, very important. Are you okay? Yes. So please, this video, understand it, because in our subsequent videos, I might be applying the source transformation at all angles. So understand the video very well. Then you'll be saved from the next videos I'll be making. Do you get it? Okay. Let's say I have a resistor, right, which is in series to a current. Can I apply a source transformation here? Yes or no? So can I apply a source transformation here? The answer is a big no. Are you okay? No, I cannot apply source transformation at this circuit. Source transformation do not hold here because transformation do not hold, right? Source transformation do not hold here because the current is in series. It only holds when the current is parallel towards the resistor. The same way, if let's say I have a resistor in what? In parallel towards a voltage source. Please, source transformation do not hold. It's not possible to apply source transformation here. Do you get it? Source transformation is only applied. It is only applied. Source transformation, right, is only applied when the resistor, right, is parallel towards the current source. When the resistor is what? Is parallel towards a current source, or when the resistor is in series with a voltage source. That's the only condition for applying source transformation. So this is correct. We can apply source transformation here. We can change the source from here to here, or vice versa. We can change it from this to circuit A, circuit B, right? We can change circuit A to circuit B, and you can change circuit B to circuit A based on the Ohm's law. Are you okay? But what happens to this? Let me draw this one over here. Current is in series and voltage is in parallel. No source transformation. So this is, we apply source transformation, right? Source transformation, but no source transformation. So here, we cannot apply the source transformation here. If it's like this, please don't go apply source transformation when you get a circuit like this. When the resistor is in parallel to, or is in series with a current, and or when the resistor, right, is parallel towards to a voltage. Don't apply source transformation here. Okay. But when you apply source transformation over here, you are good to go. Right? You are good to go. So that is the application of what? Ohm's law. Take note. We are done with the Ohm's law. And that is the application of the Ohm's law. Although we have numerous applications, uncountable ones, we'll be meeting them. When you are talking about KCL, KVL, you'll be meeting them. That one is very common. IoT. It's common to everybody. But the source transformation, most students don't come across this, right? It's one of the secret application of Ohm's law. That's the reason why I'm exposing you to it. So understand the source transformation and you'll be saved from analyzing a complicated circuit. IoT. So let's move on. The next thing that we are going to talk about, or the next agenda for the day, is the voltage division. Is the voltage division. Are you okay? Let me change it to come. So is the voltage division. So we are going to talk about the voltage division. Do you get it? So the rule states that if, let's say, I have a voltage here, right, in series with a set of resistors, right, I've drawn about 4 resistors, R1, R2, R3, and R4. right? So the current flowing through this, ideally they are the same, right? There is always a resistor, a current, right, for, let's say, a resistor 1. Let's call the current flowing through the resistor R2 as what? I2. The resistor flowing through as I3, right? And this one as I4. So I will say that I1 equal to what? I2 equal to I3 equal to I4. And this mounts to what? I. So in that case, current flowing through a series resistors are the same. So current flowing through series resistors, flowing through, right, through series resistors are the same, right? So when the current is flowing through the series resistors, they are the same. But the voltage, let's call this V1, V2, V3, and V4, right? So V1 is not equal to what? V2 is not equal to what? V3, and is not equal to what? V4, right? The current flowing through are not the same. And this is what leads to what? The division in voltage, right? Division in what? In voltage. Let's use a software to prove this. Let me move you straight to my software. IoT. I believe you can see my software here. Okay, so I want to quickly adjust this resistors. Let me use some resistors here. Let me copy and paste. Then let me rotate it. IoT. This is so huge. Let me change it to 220. Okay, and let me change this to, how do you call it? 1K. Okay, so let me add one more resistor. Then let me look for an instrument. Let's say the ammeter, IoT. Let me bring an ammeter on board. The ammeter is used for measuring the current flowing through what? A particular resistor. So let me measure the current here. And it's always measured in series. IoT. That's the reason why I'm placing it in series with, how do you call it? The components. So let me copy this and paste it here. After I'll do the connections. Let me delete it so that I'll make sure that there is no discontinuity. IoT. So let me also put another ammeter here. Okay, very good. So I've placed ammeters over here. IoT. Then let me bring the voltmeter. Rotate the voltmeter and place it at this end. Let me measure the voltage across all the resistors. So I'm measuring the voltage across all the resistors at this point. Then the last one, drag this wire down, drag this voltage here, and measure the voltage across this resistor. That's R3. Okay, very good. Very good. Let me expand the diagram. I will declare to you. You get it. So what happens? You drag it inside. Okay. So let's see what happens over here. The current flow. Let me do. Okay, very good. So let me click on the play and see. So what is happening here? You can see that, wait, let me drag this one a little. Or let me drag this one here. So that's very good. So let me explain the circuit here. We have a battery, right, which is connected in series with 3 resistors. The instruments do not add up. Okay, the instrument do not add up. So I have a resistor R2, R1, and R3, right? They are connected in series. So as they are connected in series, like this circuit, like the circuit over here, like the circuit that we are analyzing, right? V1, V2, V3. The only difference is that we don't have the R4, right? We are just using 3 resistors. So what happens over here? If I click on play, what I see, you can see that the current here is 6.25 milliamp. The same applies to this. The same applies to this. The value do not change. They are the same. But what about the voltage? We have different voltages. We have R2 is having a 1.34 voltage across it. The R1 is having a 1.37 voltage across it. And the R3 is having a voltage of 6.25 across it. IoT. So it means that the voltages are different, but the current is the same. So that is the rule. Do you get it? When we have resistors in series, then pause it and let's move on to our board. IoT. Very good. So it means when I have it, the current flowing through it is the same, but the voltage are different. And that leads towards the voltage division. Let's prove it. Today our main goal is to prove it. IoT. Is to apply it and drive a formula from what? From the voltage division. So assuming I'm going to use just, let's say, let me use, should I use 3 resistors? Okay, let me apply 3 resistors. Let me use 3 resistors. But you can use as many resistors as you can. IoT. You can just use only 2. And you can use as many. And they are all the same. You get it. Let's call this one V. Right. That is plus minus. Sorry, I've interchanged the symbol. Okay. So I have plus minus here and I have V here. Right. Or let me call it VT. I have R1 here, R2, and R3. Let me call this value, let's see, the voltage across this one as V1. And the current here as I1, right? V2, I2, and V3, I3, right? In a circuit, each resistor in a circuit, if the circuit is operating, each resistor is having a current that is passing through it. That resistor is having a voltage across it, and that resistor is having some value of resistance. So in every circuit that you can think of, we have these 3 parameters. You get it? So with this, the total current flowing through it, let's call it IT. You get it? The total current flowing through it, let me call it IT. IT is flowing through it. IT. So what are the rules? We made it clear that at this point, the I's are the same. So I1 equal to what? I2 equal to what? I3, right? And that is equal to what? IT. So let's call this equation 1. And what equation again do we need? We know that V1 is not equal to what? V2, and it's not equal to V3, and it's not equal to what? VT. The values are not the same. You should take note. You see, during my first video, I'll put the link in the description. I talk about how to determine the polarities of a resistor. And that application is needed here. So you see, if you don't watch my videos and you just jump to the middle of the video, you'll find yourself confusing unless you already know it. So you need to watch that video, the fundamentals of what? Of the circuit analysis. So please watch that video. So I'm not going to explain it over here, but you're going to see me applying it in this video. So here we say it is conventional flow, right? Since there is a rise in the voltage, there is going to be what? A fall. Since there is a rise in the current flow in the voltage, there will be a fall. So here is going to be plus, minus, and plus, minus. Do you get it? So that is going to be the polarities of the resistors. Are you okay? And once we have that polarity, we can write a KVL, which I've not explained. In my next video, I'll talk about KVL. Are you okay? I'll talk about the KVL and I'll talk about the KCL. So with KVL, right, I'll say that the voltage, the total voltage, is equal to what? The sum of all the voltages. That is V1 plus V2 plus V3. We are going to talk about it. Or even let me give you an idea. Right? I want to sum up all these voltages, all the voltages over here. I want to sum them up. So how do I do to sum them up? Let's start. I want to sum all the voltages up. I'm moving from point A, B, C, D, A. I'm moving through loop A, B, C, D, A. Right? So at this point, the voltage here, the first sign that I see is what? Is plus. Is minus. Right? So it's going to be minus VT. Are you okay? Now I've moved from A to B. I'm moving from B to C. There are two voltages here, V1 and V2, right? When I got to the resistor R1, the first sign that I saw was what? Was plus. So I'm going to get plus V1. Are you okay? Then I move to the resistor R2. The first sign that I saw was plus. So it's going to be what? Plus what? V2. Are you okay? Then I move towards C. Now I'm moving from C to D. The resistor that I saw here, the first sign was what? Plus. So I'm going to get plus what? Plus V3. And the sum of all this will be what? Equal to 0. Don't worry if you are confused. We will talk about KVL and you understand it very well. Are you okay? So here, how to be VT? Let me make VT the subject. So I'm sending VT to the other side of the equation. It means I'm going to get VT equal to what? V1 plus V2 plus V3. What is Ohm's law? Ohm's law says that V equal to what? IR. Right? So you can replace the V here with IR. The V's here. So you can see that VT equal to what? I1 what? R1 plus I2 R2 plus I3 R3. Are you okay? Okay, so let's also replace the VT. Are you okay? So the VT2 will be what? IT RT. Do you get it? Are you okay? So here, what do we have here? Let's move to the new board. So what do we have? We've got it to equation. We said that IT equal to what? I1 equal to I2 equal to what? I3. Right? Then we've also gotten this to be equation 1. We've also got the ITRT, right, equal to what? I1 R1 plus I2 R2 plus I3 R3. You get it? Since IT can be used in replacing all of them. You get it? How do we get now? We can say that IT RT equal to what? IT R1 plus IT R2 plus IT R3. Because IT is the same as I1, is the same as I2, is the same as I3. IT. So let's make IT, let's factorize IT out here. So IT equal to what? R1 plus R2 plus R3, right? So with this, if you should cancel out IT, right, what do we get? We get RT, that is, if you divide both sides, let me not skip a step so that students will be confused. So if I divide both sides by what? IT, right, what do I get? I'm going to get RT equal to what? R1 plus R2 plus R3, right? And this proves that when resistors are in series, we add them. So when resistors are in series, we add them. So let's call this equation 3. Now let's visit back to the circuit. From here, if you want to find the voltage V1, if you want to find V1, we made it clear that V1 equal to what? I1 R1. Just V1. If you are looking for V1, V1 is going to be I1 R1. So let's apply it in our circuit here. So we can say that the voltage across the first resistor, that is R1, can be given as V1 equal to what? I1 R1. Do you get it? Yes. But what is VT? VT equal to what? IT RT. You are in agreement? Yes. So we can replace I1 with IT. We know that I1 equal to IT. So in this case, we can say that V1 equal to what? IT R1. Do you get it? Yes. So if you should make IT the subject in this equation, let's call it equation 4. If you should replace VT or IT, right, over here, making IT the subject, IT should be equal to what? VT on what? On RT, right? So let's substitute this into the equation. We can get V1 equal to what? VT on what? On RT times what? R1, right? But we know that RT is equal to R1 plus R2 plus R3. So in that case, V1, the voltage across V1 can be what? Can be R1 all on what? RT times the VT, right? R1 divided by what? RT times the VT, which is the same as VT equal to what? R1 all on what? R1 plus R2 plus R3 times VT. Do you get it? Yes. So to find the voltage across this resistor, it's going to be R1 divided by R1 plus R2 plus R3. Nobody is going to ask you to prove. I just prove it for you to appreciate the concept. So nobody is going to ask you to prove this. Are you okay? Nobody is going to ask you to prove this. But let's imagine you get the voltage, and let's say you are only having a resistance. Are you okay? You have a set of resistors. Let me draw the circuit here again. I have a voltage source here. Then, how do you call it? I have a voltage source here. And with this, let's say I have a resistor here. I have a resistor here. And I have a resistor here. Let me make it as many as possible. Okay. And I have my voltage of VT. So R1, R2, R3, R4, and R5. And I have my V1 here. Right? And the question asks me to find the voltage across the resistor R1. Okay. The basic formula is going to be the V1 equal to what? That particular resistor as a numerator. That particular resistor. The R1. R1 as a numerator. All divided by what? The sum of the resistors. That is R1 plus R2 plus R3 plus R4 plus R5. Right? All multiplied by, so all this one, let me put a bracket, sorry. So all this one multiplied by what? By the total voltage, which is VT. Do you get it? So just assume that I'm rather asked to find V2. Maybe I'm asked to find the voltage across the 2 ohm resistor. So you can pause the video and write the formula. Then you visit it again. Okay, so with V2, right, ought to be V2. V2 will simply be what? That particular resistor, which is R2, right, all divided by the sum of the resistors, which are what? R1 plus R2 plus R3 plus R4, right, plus R5. All multiplied by what? By the total voltage. So this is the formula for voltage division. Do you get it? So if let's say I have V3, right? Let me use a different marker. Okay. So if let's say I'm asked to rather find V3. Right? So what will be V3? V3 will be what? Will be R3 all on what? R1 plus R2 plus R3 plus R4 plus R5. Right? All multiplied by what? By VT. Do you get it? And what is going to be, let's say, V4. I'm asked to find V4. So V4 is going to be what? R1, R4, all on what? R1 plus R2 plus R3 plus R4, all multiplied by what? By VT. And so on and so forth. Okay, please, I'm pleading with you. I don't want my videos to exceed an hour. Okay. All the videos that I make, I don't want them to exceed an hour. So, looking at the time that I spent, I'm just going to solve one question under the voltage division. It's left with the current division. In the next 2 days, or let's say a day, right, in the next 2 days, I'll try to make a video on the current division. It's going to be a very short video. I don't want my video to exceed an hour. So I'll try as much as possible to make a very short video on the current division. So stay in touch. Subscribe to the channel. And I'll make a current division video alone. So that I don't exceed the time I've set for myself. The goal is that I want everybody on this platform to understand. That's the reason why I'm taking my time to go through it. Some of you are already experts, but please let's also get time for those who are slow learners. They always need to get enough time to understand what they are doing here. My goal is not to just help those who already know, but my goal is to make sure that the weakest among those who have been watching my video will understand what I'm doing over here. Okay. So I'll end at the voltage division. Let me solve just a question. Okay, let me solve just a question over here with the voltage division. I'm going to create a question for my thoughts. So just appreciate it when, let's say, I say the question. So for instance, I have a complicated circuit here. Let me draw a complicated circuit, small, not a complicated one, of course. Right. Then I have two resistors here. Okay, let me apply just a simple circuit. I'm coming. Okay, so sorry for the delay. Right. So let me draw a simple circuit here. A voltage here, and I have 8 ohms here. I also have, let's say, 10 ohms, right? Then I have 3 ohms here. Let me use this simple circuit. Then I have my 10 volts here. You get it? And I'm asked to find V1. Find the voltage across the 3 ohm resistor. See, with this one, all that I need to do is to say that V1 equal to what? Let me call this one R1, R2, and R3. So I'll label the letters over there. So it's going to be R1 all on what? R1 plus R2 plus R3 multiplied by what? The total voltage, VT. So in that case, I have V1 to be what? To be 3 on 8 plus 10 plus 3. IAT. Multiply by what? 10. And what do I get? I'm going to get 3 on what? On 21, right? Times 10. And this one will give us 30 on 21 volts. IAT. So that will be the voltage across the what? The V1 resistor. R1 resistor. IAT. So that's it. I'm going to end here. But please, try as much as possible to understand the concept. If you are struggling to get it, just watch the video again and everything is going to be fine. I wish you all the best, and I'll come back again to talk about the current division. That is the next thing that we need to do. But I'll come back again, or my next video will talk about current division. It's very, very important. So once I'm done with current division, then I'll move on to the KVL, KCL. I'm giving you the foresight so that when you come on board, you know what you'll be doing over here. So please, try to watch this video, understand, and don't forget to subscribe. Please, I'm pleading with you. This is a short video, right? So subscribe to my channel. Subscribe to my channel for me. That's the only way you can pay back. I just want you to understand that what we are doing here is to help you, and I'm putting in more effort to do that. So please try as much as possible to subscribe to my channel. So see you another time, and I believe now voltage division is easy for you. I'll make sure I explain the current division. In the next 2 days, expect a video on the current division. Then we'll move on. Okay, enjoy the rest of your day. Bye-bye.